ceremonies. We appreciate that. Daniel is the co-chair of the Biomass R&D Board and Assistant Secretary to the Office of Energy Efficiency and Renewable Energy.
Thanks, Devin.
Thank you, Daniel.
Thank you very much. I realized, yeah, we can begin hopefully whatever's going on because with Valerie's situation could be resolved since she's the moderator, but we're flexible. Hopefully that's one of the things that we have learned in this whole virtual world is to be flexible in times like this. Yeah, my name is Daniel Simmons. I'm the Assistant Secretary for the Office of Energy Efficiency and Renewable Energy. And thank you to Valerie, thank you to Devin, thank you for everyone that is a part of the Biomass R&D Board and the Biomass R&D Operations Committee for actually making this meeting happen today. I really appreciate it, and thank you to all of you that are joining us that have an interest in this topic and want to work with with all of the federal agencies, as well as for the federal agencies to do a better job of working together. That is a real a key area for us to make sure that we are doing a good job working across the federal government on this issue. So again, thank you for your interest in the Bioeconomy Initiative. The Department of Energy, we are focused on advancing price competitive biofuels, bioproducts, and the overall bioeconomy. In our meetings the past few years with industry, one of the things that we've really heard is a desire, whether it is for automotive, heavy trucking, for aviation fuels, is to have more renewable fuels, and hopefully for them to be drop-in fuels. And so that's something that we are focused on. So and the good news is this is a key effort for our Bioenergy Technology Office, and it presents real opportunities in the transportation sector, as well as one of the things we'll mention, some very interesting things in terms of bioproducts. Since 2014, our Bioenergy Technology Office has contributed to a nearly 50% reduction in advanced biofuel cost. That is fantastic, but we still need to do more. And so despite the progress that we have made, we are constantly looking forward to what we can do in the future to continue to move the ball forward. And so today I wanted to reaffirm the Department of Energy's commitment to the Bioeconomy Initiative and share some recent examples of some actions that taken by our Bioenergy Technology Office toward our shared mission. One common thread across these efforts is a spirit of collaboration, that this work would not have been possible without our partnerships with industry, with the National Lab, and other Department of Energy offices. On July 31st, the Department of Energy announced $97 million of funding for 33 projects to support technology research and development to accelerate the bioeconomy. These will support production of biofuels, biopower, and bioproducts from biomass and waste resources to help improve their performance, lower the cost, and reduce risk. With this funding opportunity, we made sure that the topics addressed supply chain innovation areas identified in the Bioeconomy Initiative implementation framework. The initiative goals for these new projects include scaling up technologies to support commercialization, making new waste energy feedstocks more economical, and the delivery of environmentally restorative benefits by planting bioenergy crops. These projects will help make the U.S. a leader in the growing global bioeconomy and help provide American consumers and businesses with more homegrown options for fuel, but also for projects. The technology transfer and industrial partnerships are both recognized as fundamental actions to support the bioeconomy and the implementation framework. Whenever possible, we partner with industry, and a recent example of that is with a set of projects coordinated by our Agile Biofoundry Consortium. On July 10th, we announced the selection of 8 projects totaling more than $5 million for research and development to help accelerate the biomanufacturing sector. As part of the Agile Biofoundry Consortium, These 8 companies will work with our national labs to develop novel microbial hosts and bioproducts using artificial intelligence and machine learning. This work supports the mission of the Conversion Interagency Working Group. Another valuable resource for biotechnology industry is BETO-supported Advanced Biofuel and Bioproducts Process Development Unit at Lawrence Berkeley National Laboratory. This unit acts as a scale-up testbed for collaborators developing technologies that transform raw materials such as plants and waste into bioproducts. And we are pleased to share that in May, the Advanced Biofuels and Bioproducts Processing Development Unit celebrated its 50th industry partnership since its creation 8 years ago. Several partners have launched products after working with the unit, and these include Ginkgo Bioworks, Geltor, Perfect Day, and Ripple Foods. In addition to working with industry, it is critically important that we are working across offices within my office, the Office of Energy Efficiency and Renewable Energy, to advance departmental priorities. For example, our Bioenergy Technology Office is working with our Advanced Manufacturing Office and the Office of Science on the Department of Energy's Plastics Innovation Challenge. This is a comprehensive program to accelerate innovations in energy-efficient plastics recycling technology. And as part of this challenge, in March, we announced a new funding opportunity of up to $25 million to support the development of new plastics that are inherently recyclable by design. This work is also looking to find ways of breaking down existing plastics into chemical building blocks that can be used to make higher value products. And we have received many excellent applications, and we are currently in the process of selecting the projects that will support this new initiative. So our greatest asset, as you've heard me emphasize today, is the spirit of collaboration. All of the efforts I discussed today involve working closely with industry partners, with our national labs, and with other offices in the Department of Energy. And of course, thank you to all of you for this important collaboration that is the Bioeconomy Initiative. Collaboration is critical for our success, and we are proud to work with the Department of Agriculture, with EPA, with Interior, with the National Science Foundation, the Department of Transportation, the Office of Science, Technology, and Policy, and the Navy. And we, because by combining expertise and resources, our agencies working together can be much more effective than we would otherwise be alone as we achieve the goals of the Bioeconomy Initiative. And I'm inspired by the fact that despite current circumstances, we are able to continue working together to advance the bioeconomy, and very excited to hear from other partners during today's event. Thank you very much. Back to you, Devin, or
let's hope. Can you
Devin
hear
or
me?
Valerie? Yes, we can.
Oh, great. Thank you so much, Stacy and team, for fixing my audio issues. And thank you, Daniel, for that opening. Discussion is really a big part of what we want to do today. So building off of Daniel's comments, we have a bunch of questions that we would like to pose to our panel. But before we do that, I would really like to introduce our additional 3 panel members today. First, we have Charlene Weatherwax. Charlene has been with the Department of Energy's Office of Science in the Biological and Environmental Research arm. She is responsible for federal funding that goes into a number of key areas, most specifically, in her case, biological and environmental sciences. She does strategic program planning, budget formulation and execution, program integration, and works closely with the DOE applied offices such as the Bioenergy Technologies Office, as well as other agencies. She previously served in a number of different positions across the department, including Division Director and Program Manager for Biological Systems Science Division, as well as a Program Manager in the Office of Basic Energy Sciences. We also have today Dr. Richard Dixon. He is currently serving as the National Science Foundation Division Director of the Division of Chemical Bioengineering, Environmental and Transport Systems. And he has served as the chair of the University of Florida Department of Chemical Engineering for 8 years. Dr. Dixon's research applies engineering principles to study the behavior of living cells and other small-scale biological systems. He uses a combination of engineering, modeling, analysis, quantitative experimentation, and the tools of molecular cell biology to better understand the relationship between cell function and the physical and molecular properties of cells and their environment. And last but not least, we have Dr. Jean Lester. As the national program leader within the U.S. Department of Agriculture, Jean plans research objectives, allocates personnel, as well as budgets to science-based research programs. And he's currently directing 2 national programs, biorefining and biofuels, which looks at biorefining and bioproduct conversion of lignocellulosic feedstocks, as well as sugar crop bagasse. And his second program is product quality and new uses, which is post-harvest plant and animal food processing and quality preservation and new uses of plant and animal fibers. So thank you all for being here today. The audience has voted on a number of priority questions they would like us to address today. And the first question we have is in the topic area of bioproducts. What are the offices doing to tackle research and development challenges to develop cost-competitive bioproducts from biomass? I think I'd like to start with Daniel Simmons and see if he would like to address that question for us.
Sure. One of the things that we're doing is having a focus on performance advantaged things that have some type of performance advantage. And on July 2nd of this year, we announced 7 projects totaling about $2 million to conduct R&D to accelerate the adoption of performance advantaged biofuel blend stocks. And that's one of the keys is that there are certain things for which the bio-derived components are perform at a higher level than does something derived from petroleum. So that is a key area to have that focus. In that case, one of the things that we're doing is are working with our vehicle technology office on a program called Co-Optima, which is co-optimizing engines and fuels together, and to look at how we can improve through that co-optimization. So with that, Valerie?
Yes.
I'd also like to hear from you, your thoughts on, with that same question, as well as the rest of the panel. But I didn't get a chance to tell you that either earlier. So after you hear from the panel, I'd also be curious to hear your thoughts.
Absolutely. I will be prepared to answer the question as well, but let's turn our attentions right now to Dr. Dickinson and hear what your opinion is based on NSF experience.
Yeah, thank you. So NSF, as I think many people know, it's a little bit different in mission than some of the other agencies on the panel. So we fund research across all science and engineering. And most of our core programs are organized around disciplines. So for topics in this area and other areas, it's usually a matter of matching what are the fundamental research questions and within that discipline that sort of fit in that application space. So in my division, we fund a lot of work in this area, probably mostly in the cellular and molecular bioengineering program. And just to give you some of the types of projects we funded recently, valorization of wastewater biomass to produce value-added chemicals and power, pyrolysis of biomass towards higher valued products, biomass conversion technologies using biocatalysis. So these are all in core programs, and usually these come in the form of unsolicited proposals on the order of $400,000, single investigators. But we also have lots of opportunities for larger collaborative multidisciplinary projects, which in NSF we like to call convergence, so big problems that require multidisciplinary teams. So a nice thing about NSF too is that we've we have a spectrum of disciplines represented all the way from economics, behavioral science, to physics, and et cetera, and engineering. One of the initiatives for these larger team projects that we just awarded several projects is in the area of future manufacturing, and some of the subtopics there are in biomanufacturing as well as eco-manufacturing. And I'll just to highlight one as an example. So we funded a large project with the PI of Jay Kiesling from Berkeley, entitled Digital Light Manufacturing for the Circular Economy. In this case, the team is engineering organisms to synthesize monomers from biomass sugars to generate resins that are going to be used in 3D printing applications, and that are also easy to depolymerize, so you can recover the monomers for additional use with the circular economy in mind. Another program that comes out of an office in engineering is a program called Emerging Frontiers for Research and Innovation. And they publish 2 topics every year for 2 consecutive years. And the topics currently, one is on end-of-life plastics, and the other, which is more relevant here, probably is distributed chemical manufacturing. So basically bringing the manufacturing to the feedstock. And in that case, we funded a project from the University of Washington called Synthetic Biology Processing Units for Distributed Manufacturing of High-Value Products. Another opportunity for research in the space is the Engineering Research Centers. These are large centers, typically on the order of $4 to $5 million a year for up to 10 years. And we funded a new one this year in the area of Internet of Things for precision agriculture. A couple of graduated ERCs, graduating in that they recently ended, but they are continuing in some form. One is for the Center of Biorenewable Chemicals, or CBERC, and the other, which is had a huge impact, I think, in the field of synthetic biology, is the center, the Berkeley Center for Synthetic Biology. Lastly, let me just mention another program. So opportunities for industry to collaborate with academic institutions. There's an industry university collaborative research program called the IUCRC. And a couple of the topics that have been funded there recently, one is a Center for Advanced Forestry Systems, and another is a Center for Bioplastics and Biocomposites. So there's really a spectrum, just to summarize, spectrum of opportunities. If people are interested in doing fundamental research in this space, so everything, NSF funds fundamental research, so when it's use inspired, it has to be early stage and have broad impact potential. High risk, high reward is certainly welcome. So hopefully that covers NSF's perspective on this question.
Excellent. Thank you so much. Let's turn now to Charlene and the Office of Science's perspective on the question related to bioproducts and how we're trying to overcome R&D challenges.
Thanks, Valerie. So, I think I'm going to highlight one thing that is really unique to the Department of Energy's Office of Science, and that is our support for user facilities. So these are facilities that we support and we sustain, and we have instrumentation, we have a lot of high-tech tools and approaches, we have skilled technical staff, and people apply to use them by bringing their ideas. And one of the things that we think about as being very important to underpin when you're deciding what kind of bioproduct you could make is, well, what's already out there and what can I do to either improve or reinvent something? And so that's where, for example, our genomic sequencing facility, the Joint Genome Institute at Lawrence Berkeley National Lab, plays a big role. It will sequence all the genetic, complement of maybe a fungus that's going to break down biomass, or maybe a microbe that will put together different kinds of building blocks in different ways, or even higher plants or trees. What exactly is in their raw materials that you could break down and then transform into something that would be of a higher value or different value. And so these are examples of things where the community can kind of get involved and they can put proposals in, and then the user facility will give them the data back, and it's all in the public domain, and then it becomes very democratized. So everybody then can take a look at it and say, oh, I didn't realize that this microbe had this pathway to do this. Maybe what I'll do is add an extra pathway, and now it can generate this new product. And so that's the kind of thing that we're hoping to facilitate. We also have facilities to, once you've made a product, to actually figure out what you think you've made. And so characterization is a big key. We have light sources, neutron sources, synchrotrons all across the country. We have cryo-EM facilities. We have real high-tech instrumentation at the Environmental Molecular Science Lab. These are all ways that you can actually bring your sample and then have it tested to see, is it what you think it is? Maybe you created a new enzyme and you don't know how to characterize it. So these are things where the use of facilities will help you. And so, I think some great examples that we've had in the past is where the technology offices have put forward some key targets. Like, I wish we knew more about these kinds of plants or these kinds of microbes. And our user facilities have responded by helping to get that genome sequencing information so that everybody can then take a look at it and then, come up with their own ideas to innovate and make some new bioproducts. So I think that's good for what I want to say for this part now, Valerie.
Great, thank you. Jean, I know there's a lot of work going on with new uses and bioproduct development at USDA. So if you'd like to share with us now, that'd be great.
Thank you, Valerie. The USDA, we have basically 4 centers that were established 80 years ago. And one of the major things that we're proud to have is at our center in Peoria, Illinois, is the world's largest collection of microorganisms, which we have the opportunity to exploit on a regular basis. And in doing so, many industry individuals, university individuals, and our other partners in DOE, for an example, will come and partner with us to solve a number of problems. And for an example, we've developed a fungal source that removes the inhibitory chemicals in biorefining recycling of water. And recycling the water is important, so to clean it up and keep it using helps keep the cost down. We discovered new yeast strains along with an helical stirring procedure that reduces the amount of enzymes needed during saccharification and fermentation. We've determined key proteins in yeast strains, which serves as a selection criteria to detoxify inhibitory chemicals in the pretreatment of lignocellulosic biomass. We've also discovered microbes that make xylitol in a cost-effective process from plant sugars, and particularly xylose, which is a waste biomass by and large. And we've also discovered an alcohol-tolerant bacteria for use in the fermentation of biofuels, which helps lower the cost of ethanol and butanol production. So in our facilities, whether it be Peoria, Philadelphia, San Francisco, or New Orleans, our facilities, we're there to work with any and all partners to advance breakthroughs in the technological area. Thank you.
Thanks, Jean. And those 3 presentations couldn't be more appropriate for leading into what Bioenergy Technologies Office does looking into the bioproduct space. We heard about innovations and discovery and tools that could enable the industry to look at what bioproducts are possible. And the importance of the bioproducts within the bioeconomy equation is that these often are higher value. They bring a higher value earlier on in the process than, say, a biofuel would, which, while it may be produced at large volumes, has to be very low cost in order to compete in the market. So as we look at the bioeconomy equation, we can learn a lot early on, partnering with industry to help develop the bioproduct equation, which becomes a win-win. They win because they have products that can be commercialized and they can begin to make a profit. And we win because we are able to demonstrate incredibly high-risk technologies, particularly associated with scaling up some of the processes that underlie the production of biofuels. So it's very important for us to be able to consider the entire barrel of oil, and that we need both the fuels and the products. And we can learn a lot and reduce risk on the engineering scale earlier when it's related to bioproducts. One example of this that I'd like to share is within our algae program. So we all know that algae is an incredible organism that can do a lot of things, and the bioenergy program is trying to harness that activity to be able to produce biofuels at very low cost. Along the way, we work with a number of industry partners who have interest in using algae for a variety of reasons. For instance, the company Algix is working with us, and they have launched a line of foams coming from algal oils that are being used in footwear today and are being sold. And the story that is told that goes with this footwear for the consumer is about the environmental benefits, such as cleaner water and sequestered carbon dioxide, that is basically the result of every pair of shoes that is purchased and the material within them. Algix recently doubled their output in their Mississippi factory, and they're producing on the order of 20 million pairs of shoes this year. And so that's a lot of information that's getting out into the private sector, into the public, about the benefits of these renewable resources and how they might be used industrially and then ultimately in the energy space. So I think I'll stop there because we have additional questions that are of interest to our audience. So I'm going to shift to the next question, which is on scaling transformative technologies. So the question is, what funding opportunities are there between the agencies here to financially assist in scaling up through demonstration these transformative technologies? I think I'll start with Dr. Lester.
Okay, thank you. We of course are able to utilize small business innovation research grants, and we also have grant funding opportunity within the Agricultural Research Service to dealing with scaling transformative technologies. And for an example, we've worked with the Corn Growers Association, and we've made food-grade emulsifiers from corn stover that can be used in salad dressings and ice cream. We've also worked with startup companies developing plant-based oils that can be used at 2% level versus the current 40% level of helping for performance of high-sulfur diesel fuels. Dr. Hutchins yesterday mentioned Estilides, which we developed as a plant-based motor oil that improves mileage, performance, and keeps engine clean. And that was done with a startup company that basically came and worked with us with little or no cost at their point. They just had an idea on moving forward. We've also worked with some university people in making reversible antimicrobials. That's a very simple process as opposed to most microbials from fossil fuels, which exist in the environment, allowing for antimicrobial resistance. These reversible antimicrobials break down to their starting molecules, and they're basically innocuous. And we're currently working with universities and DOE on plastics from biomass that will dissolve in the oceans. So we have many opportunities, both funded, non-funded, just intellectual property standpoint, or just a person wanting to come and work with us. All of those collaborative research and development opportunities are available.
That's great, Gene. And I do want to talk to you more about that Oceans Plastics project when we get a chance. I think that I'd like to continue from my previous answer on bioproducts to address this one, if I could, for a moment. Scale up is incredibly important, especially since we're trying to develop an industry that, for the most part, doesn't exist yet. Biofuels exist when it comes to starch-based ethanol or biodiesel, but as we talk about the more complex equation associated with using lignocellulosics and algae for the production of fuels and chemicals, there's a much more complicated technical equation going on here. And a lot of this needs to be demonstrated not only at the bench with the great research that you've heard about going on across all the agencies, but also as we move towards a commercial facility, we need to take our time and scale these technologies up appropriately in order to ensure that we don't run into any issues on integration, or as the scale increases, what might happen at an engineering level. When those types of things occur, that can drive our research platforms to try to overcome the issues that add risk and therefore financial risk to finally developing a commercial facility. Our program at the Bioenergy Technologies Office has a scale-up program in which we put out, hopefully on an annual basis as appropriations are willing, additional opportunities for technologies to work their way up the scale. In FY20, building off of Daniel's earlier comments where he mentioned are awarding $97 million worth of research projects, a major portion of that funding went into a topic called Scale Up of Bench Applications. We like to call that SCUBA for short. And what we were looking for here were process steps or integrating process steps that had shown promise at the bench, but needed to go up to the next scale. So therefore, this is greater than bench scale, but perhaps not as great as pilot scale. We awarded 8 projects, a total of $29.5 million in government funding. And so that's an exciting step forward for a lot of technologies that have been in development from our partners in national labs up until now. Our next phase would be to go to pilot scale. And pilot for us typically means an integration of process steps at a much higher, maybe 10% higher or tenfold higher scale. This can be very useful to the company who's looking at the final product, whether it be an intermediate or a fuel, and wanting to do some consumer testing or product testing of that, so they can assure they're meeting standards that are appropriate for the industry. And so the pilot scale helps them do that while verifying across the board what the cost of the final product might be, as well as any hiccups that we need to take back to the bench for research and development. Our last and probably the most difficult phase of scale-up is demonstration. This is incredibly expensive, as you can imagine. Biorefineries on the order of $100 to $200 million, and even more, are going to be what we need when we're building out a biorefining industry. And so this demonstration scale is an expensive test facility that is working towards finalizing the engineering design for commercial financing. So the government plays a role here because of the cost associated with this, and so we can help buy down that risk. So within our scale-up strategy, we will go as high as the demonstration facilities if the projects have met the metrics all along that way to prove that they're ready to move into that space. So hopefully that gives you kind of a picture of what it looks like to take an innovation from its earliest conception all the way through to a final commercial product. All right. If I could, I'd like to move on to the next question because it kind of changes direction just a little bit for the audience, and we are running out of time. This will be our last question, I believe, and this one is on CO2 utilization and sequestration. The question is, what are the current and future programs that use biomass and biochemical components to store electrical energy, CO2, and then utilize this to potential products? And what about CO2 sequestration? Okay, so if we could, perhaps, Daniel, would you like a chance to address this?
Sure. And I did take myself off mute, which is always a good thing. You know, when it comes to CO2 sequestration, there needs to be it can't be just a negative. We need to be, if this is going to happen, it needs to be, you know, we need to do something with this, with the CO2. It has to be utilized in some way, and that's in this year, FY20, we announced $7.5 million in funding for scalable CO2 electrocatalysis. Obviously, this is a new-ish area. We are a long way from making electrocatalysis a cost-effective reality. But we announced 3 project selections in July 31st, and we are looking at how to use these technologies because of CO2's potential as a high-volume feedstock. Now, obviously, we need to sequester it, but once it's sequestered, it is so much better if we can then turn it into a fuel as opposed to just putting it into the ground. As in, it just needs to have that value. So we're excited about the opportunities, though. You know, we definitely have a ways to go to do it in a cost-effective way. But it's a key area for us.
Thank you, Charlene. Would you like a chance?
Sure. So when we think about CO2 sequestration, we naturally think about plants because that's one of the things that they're born to do. And, you know, a lot of what we've done is try to understand, you know, what are the balances that are required in order for plants to actually take up CO2, grow out their root systems, you know, have healthy rhizospheres. And so what's the relationship between plants and the microbes that are associated with that? And so that's a big part of what we want to know because, you know, we're interested in actually sequestering it for a long time down there in the soil, and then it can possibly serve as a feedstock for lots of other microbes that are going to be doing things with it. And some of that could be genetically engineered, but a lot of it really depends on the balance of nutrients and all the nutrients that are cycling through the ecosystem. So that's something that we're really focused on understanding.
Thank you. Our last speaker on the subject, if we could, would be Dr. Dickinson.
Thank you. So similar to my last answer, NSF is organized around disciplines, and we fund many different projects, fundamental projects, research projects in the space in the core programs. While we don't have a program identified specifically for example, CO2 sequestration, you'll find funded projects across the bio directorate, engineering, geo, and other directorates as well. So it's really critical to try to identify what the fundamental research questions in that project and try to align them with the program description. So, of course, you can go to nsf.gov and see all the program descriptions for the core programs. Let me just mention in my division, CBED, the Chemical Bioengineering, Environmental, and Transport Systems, has 16 programs. Several of them fund research in this general area. There's one program that is explicit in mentioning bioconversion to fuels and chemicals, and that's the title of that program is called Process Systems Reaction Engineering and Molecular Thermodynamics, kind of a mouthful. And I also mentioned the Cellular and Molecular Bioengineering program, which is more fundamentally interested in how to engineer cells for biomanufacturing. We also have an environmental sustainability program, so these may be issues in green engineering and circular economy, sort of the larger scale questions. We have electrochemical systems program, so it's more focused on the electrochemical energy storage end of it. And then we also have a catalysis program, and chemistry division also has a catalysis program. Our program is more geared with an eye on engineering applications. So it really depends on what are the key questions to see where it's a good fit, and we always recommend the best way to determine that is, of course, check out the program description at the website and then have a conversation with the program director to make sure it's a fit for going ahead and submitting to that. And I also mentioned some of the larger multidisciplinary programs. All those sometimes will focus on more narrowly on certain application areas. I can't identify one currently in this space, but that doesn't rule out one appearing in the near future.
Thank you. Thank you very much. And I want to thank the entire panel for your time and attention, and to the audience for your prioritization of questions. I wish we could have gotten to more, but there is more ahead if you stay